Hello students, welcome back to another session in this unit number 3. Today we will see air refrigeration system. So in this unit these are all the topics we have come across, and today we are going to discuss the air refrigeration system, and these topics already we have completed. In next session we are going to start magnetic refrigeration system and vertex tube refrigeration system. So this will be in one more session, and I need one more session to complete the pulse tube refrigeration system. Again, vertex tube and pulse tube refrigeration systems are very simple. We can complete in very quick sessions. So introduction to air refrigeration system. Here air refrigeration system, all along we have seen about air refrigeration systems only. So specifically what are its advantages and what is air refrigeration system, that we will discuss in this session. Air refrigeration systems are category of refrigeration technology that utilizes air as the refrigerant, and they are widely used in applications where mechanical refrigeration might be impractical due to specific constraints such as environmental conditions, space limitations, or simplicity of operation. Unlike conventional systems, they rely on gases like freon or ammonia. Air refrigeration systems are use compressed air only. So this air refrigeration system uses compressed air instead of refrigerants like freon or ammonia. So here air is used as refrigerant, which undergoes expansion, compression and cooling process to absorb and remove the heat. So here also we have four processes like earlier vapor absorption and vapor compression systems. So here we have expansion, compression and cooling processes to absorb heat, remove heat. So air refrigeration systems have been extensively used in applications such as aircraft, so especially for cooling cabin air, and refrigerated transport, where cryogenic applications, low temperature refrigeration in spaces where the use of traditional refrigerant is either not feasible or undesirable. So in that cases, the wherever we cannot employ our conventional refrigeration systems, there we can use this air refrigeration system. So basic principles of air refrigeration systems. An air refrigeration system works on the basic principles of thermodynamics, specifically utilizing the Joule-Thomson effect, Boyle's law and Charles' law. So these are the basic laws of thermodynamics. So the first one is Joule-Thomson effect. This refers to the temperature change in gas when it is allowed to expand without doing any work. So this is very simple effect where it refers to the temperature change in a gas when it is allowed to expand without doing any work. So without the exchange of heat, so the exchange of heat is not happening here. For air, the Joule-Thomson effect typically results in cooling when the air expands. So second law is the Boyle's law. This law states that the pressure of a given mass of gas is inversely proportional to its volume at constant temperature. So here this is the temperature is held constant, and the pressure is inversely proportional to volume. So this is the simple law, Boyle's law. And Charles' law, we have this law states that the volume of a given mass of gas is directly proportional to its temperature at constant pressure. So here the pressure is kept constant and the volume is directly proportional to its temperature. So these two laws, and we have air refrigeration systems are often classified into two categories, regenerative air refrigeration systems and non-regenerative or simple air refrigeration systems. So these are the two types of air refrigeration systems. So components of air refrigeration system. The fundamental components of air refrigeration systems are similar to those in other refrigeration technologies, but with slight modification to accommodate the use of air as refrigerant. So here we are using air as refrigerant, and the components and construction all are almost same as our conventional refrigeration systems, but slight modifications are done here to accommodate air as refrigerant. The key components include compressor. So this compresses the air, increases the pressure and temperature, and expansion valve, throttling valve allows the high temperature compressed air to expand rapidly. During this expansion, the air cools down due to Joule-Thomson effect. So Joule-Thomson effect is coming into picture here in while expansion process is taking place. So evaporator, next component is evaporator. The cooled air is passed through the evaporator where it absorbs heat from the environment or the space to be cooled. So here evaporator is the space where, and it is accompanied in the refrigeration system where cooling process is taking place. So next is condenser. The last one is condenser, and these are the four major components very similar to vapor compression system or heat exchanger. Condenser is also acts as a heat exchanger. So in some systems a heat exchanger may be used to remove heat from the compressed air before it enters the expansion valve. So coming to types of air refrigeration system, there are two types as we discussed in earlier slide. And first one is simple non-regenerative type air refrigeration system. So this system operates in a basic cycle involving compression, expansion and heat absorption of the air. So the system is simple in construction but may be less efficient compared to regenerative systems. Common in small scale or portable refrigeration systems like in aircraft. And next one is regenerative air type refrigeration system. So this system incorporates a regenerator, also known as a heat exchanger, so that pre-cools the compressed air before it enters the expansion valve. So the regenerator absorbs the heat from the compressed air and uses it to preheat the incoming low pressure air. So here this leads to better efficiency as it recycles heat within the system, reducing the amount of energy required for compression. So this is another advantage here. It recycles heat within the system, and the compression energy required for compression is reduced. So used in large scale industrial applications including cold storage and air conditioning. So this is another regenerative type. Regenerative type has better applications when compared to non-regenerative type air refrigeration system. So working cycle of air refrigeration systems. Here the working cycle of air refrigeration systems can be broken down into the following stages. So first one is compression, as we have seen in our earlier topic, vapor compression refrigeration system. So air is drawn into the compressor where it is compressed to a high pressure. So here air is drawn into compressor and it is compressed to high pressure. The compression process increases the temperature of the air according to the ideal gas law. So ideal gas law is playing a role here during compression process. So cooling and condensation. So here next process is condensation. The high pressure, high temperature air is then passed through a heat exchanger or cooling coil. So here the air losses heat to the surroundings. So here the heat is dissipated to the surroundings and the temperature of the air decreases, making it easier to expand. So next process is expansion. The cooled compressed air is allowed to expand rapidly through an expansion valve. So the expansion results in a drop in air temperature. So here the Joule-Thomson effect is plays a role and causing the air to cool further. So here the expansion process cools the air further, and condensation provides cooling, and further cooling is provided by expansion valve. So next is evaporation. So evaporation is nothing but the component where it is kept in refrigeration space. So here the refrigerator, the evaporator is takes the complete heat from the substances. The low pressure cooled air is passed through the evaporator or the refrigerator space when it absorbs heat from the surroundings. This process lowers the temperature of the space or material to be cooled, and cycle repeats. So then these are the four processes taking place, and finally this cycle completely a recycle. So this cycle will repeats. The cycle repeats continuously with air being compressed, cooled, expanded, and evaporated to maintain the desired temperature. So applications of air refrigeration system, aircraft refrigeration system, and in aircrafts it is widely used. Air refrigeration systems are commonly used in aircraft to maintain cabin temperatures and keep sensitive equipment cool, and the system is preferred in these applications due to its simplicity, weight advantages, and the ability to use the compressed air from the engines. So cold storage, another application is cold storage. Air refrigeration is used in cold storage units, especially in places where electricity supply is not reliable or traditional refrigeration equipment is unsuitable, and these systems are particularly useful in remote locations. And cryogenic refrigeration, in cryogenics, air refrigeration systems are used for cooling materials to extremely low temperatures. So military applications, due to their simple design and reliability, air refrigeration systems are also used in the applications where specialized cooling systems are needed in harsh environments. So the in military applications also air refrigeration systems are widely used. So advantages of air refrigeration systems: environmental friendly. Air refrigeration systems do not rely on harmful chemicals such as freon and thus have minimal environmental impact. Simplicity and reliability. The system has fewer moving parts and less complexity, leading to lower maintenance needs. No chemical refrigerants. The use of air as a refrigerant avoids potential leaks of harmful gases that could contribute to ozone depletion or global warming. And suitability for specific applications. These systems are particularly advantageous for use in aircraft, space missions, and other specialized applications where the presence of air refrigerants could pose a problem. So coming to disadvantages: efficiency. Air refrigeration systems typically have a lower coefficient of performance compared to systems using traditional refrigerants. This means that they require more energy to achieve the same cooling effect. So limited temperature range. Air refrigeration is less effective at reaching extremely low temperatures compared to other systems using refrigerants like ammonia or freon. So large size. Due to the low efficiency, air refrigeration systems often require larger equipment or greater energy inputs to achieve the desired cooling effect. So future of air refrigeration systems. While air refrigeration systems may not be widely used in conventional refrigeration, Their simplicity, low environmental impact, and specific applications continue to make them relevant in certain applications. So future developments may focus on improving their efficiency through hybrid systems, better compressors, and integration of more advanced heat exchanger technologies. Furthermore, ongoing research into alternative refrigerants and energy efficient technologies may open up new avenues for the use of air refrigeration systems in broader applications. So to conclude, these air refrigeration systems, while not as common as traditional refrigeration methods using freon, ammonia, or other gases, are crucial in certain applications due to their simplicity, minimal environmental impact, and ease of use. As technology progresses, the efficiency of these systems may increase, making them more viable for widespread use. And understanding the basic principles, components, and their and types of air refrigeration systems is essential for those working in the fields to HVAC, aviation, or specialized cooling applications. So these are the conclusions from this air refrigeration system. And in next topic, we are going to see magnetic refrigeration system. It is little bigger topic. We will discuss in two sessions. I am going to split the magnetic refrigeration system into two sessions, and we will discuss elaborately, and we will start that in next session, students. And to refer this topic, these books are not giving much information, so hence I kindly request you to refer my notes, so that will be more than sufficient to prepare this topic. And compressor, the working of compressor, evaporator, the condenser, and throttle expansion device are very much similar to vapor compression systems. And cycle also is like, the thermodynamic cycle is also like our vapor compression refrigeration systems. We stop here. Thank you, students. We will meet again in next session, magnetic refrigeration system.